we know that the area of a triangle is just simply 1/2 base times height, right? Now, if I wanted to show what that looked like on a triangle, I could say that this right here is the base. And if I wanted to show what the height would be, we know that the height is just perpendicular to the base. So perpendicular, and so this would be the height of the triangle. Now, this is not the only way to write the area of a triangle. In fact, there's other ways. In this video, we're going to focus on finding the area of a triangle if we know these two side lengths and we measure the angle between those two sides. So, I'm going to say that this side length right here is A, and I'm going to call the angle right here theta. So, if I want the area in terms of just A, B, and theta, then I don't want it in terms of H. So I have to substitute H for something. So what I could do is I could just use the sine of theta. If I find the sine of theta, that's just opposite over hypotenuse. So I just get H over A. Now, if I solve for H, I just get H is equal to A sine theta. So all I have to do now is just substitute H for A sine theta, right? That's all I have to do. So substituting for H, we get 1/2 B times A sine theta. And we know that we can just rewrite this as area equals 1/2 AB sine theta. So this right here is the area of a triangle if we know what these two side lengths are and the angle between them. So this is just the area of a triangle. But here's the thing, you might be thinking, wait a minute, this only worked because the angle right here was an acute angle. What if this angle was obtuse? Would we still get the same thing? Let's try that out. Now what I'm basically going to do is I'm just going to make this angle wider. So what I've basically done is I've made this angle way wider. So this right here, I'm going to call this theta. Remember, theta is still in between A and B. So I'm still going to call this A and B. And we know that we have the base right here. That means we also need the height, right? Because we still got to show what the height is. Remember, the height is still perpendicular to the base. So if that's true, then what I'm going to do is to draw the height, I'm just going to extend the line right here. I'm just going to extend the base so that I can draw the height. And the height is just from this point right here. I'm just going to draw it right here. Right? It's perpendicular to the base. And so this would be the height. Right? So this length right here is the height. And this length right here is the base. Right? So, now that we know that, we are now going to basically use this. We're basically going to use this triangle now and see if we get the same area. So let's do that. Now here's the thing. We can't directly take the sine of theta because this right here isn't a right triangle. It's an obtuse triangle. We have to use this right triangle that we have right here. And in order to do that, instead of theta, I am going to use 180 degrees minus theta. Because remember, this angle and this angle right here, they're just supplementary angles. So they add to 180 degrees. So this is just 180 degrees minus theta. And this right here is still side length A, right? I'm just going to write A right there. So, area of a triangle is still 1/2 base times height, right? That doesn't change. And what we have to do is we have to do the sine of 180 degrees minus theta so we can replace H with something. So the sine of 180 degrees minus theta is still opposite over hypotenuse. So opposite over hypotenuse, H over A. Solving for H, we get this. And so this is what we get when we solve for H. We get A sine of 180 degrees minus theta. So if we substitute that into our area, we get this. So we're substituting H into what we have right here. We're substituting that into H. course, we could just rewrite this as now this looks awfully similar to what we had for area equals 1/2 AB sine theta. Instead, we have area equals 1/2 AB sine of 180 degrees minus theta. But here's the thing. The sine of 180 degrees minus theta actually equals the sine of theta. Right? This is a very important thing in what we're doing right now. And the way that we can show that this is true is by using the unit circle. So we have the top half of the unit circle right here. Now, if I said we're dealing with this angle as theta, then 180 degrees minus theta could be represented like this, where we have this as theta, and this would be 180 degrees minus theta, right? So that's what the measure of this angle right here would be. And notice how the heights of these two angles that we get right here are the same height, and as a result, right, the height here and the height here are the same. As a result, the sine of these angles are the same, right? That's what the unit circle tells us. As a result, sine of theta equals the sine of 180 degrees minus theta. So that means we could just replace the sine of 180 degrees minus theta with the sine of theta. So we get 1/2 AB sine of theta. So this is the area of a triangle, right? So it works for if theta is an acute angle or an obtuse angle, right? It could be either one. So this is another way to write the area of a triangle.